Creating your first scene in Blender. In this tutorial we will work through creating a simple room scene to familiarize you with some basic tools and concepts in Blender. We will create several models, texture and arrange the models, add lighting and textures to our scene, and finally render several images of our scene, all with the goal of telling a simple story. We will divide the work up into distinct phases to simplify the process. As with any project, going in with a plan is a great way to start. Ask yourself the following questions. 1. What is the purpose of this project? 2. Who is the target audience for this project? 3. What is the setting for this project? 4. What models are needed for this project? 5. How much time do I have to complete this project? Let's answer these questions. 1. The purpose of this project is to create a simple room scene that tells a story in Blender that will familiarize you with some of the basic tools and functions. 2. Your instructor is the target audience for this project. They will be looking to see if you are utilizing the tools and concepts discussed in this tutorial. 3. The setting of this project is a person's bedroom. We want to fill the room with objects that tell us something about the person who lives there. 4. The models needed will depend on the story you are trying to tell. Some common items might be the room, bed, desk, desktop items, chair, bookshelf, books, and other items on the shelf. 5. In this class we will work on a weekly schedule, so you will have 6 days to complete this project. I expect you to spend 3 to 5 hours in that 6-day period working on this project. Write these things down, it will help you to organize your ideas and keep you from forgetting important things. Now that we have the basic parameters established and on paper, the next step is to doodle. Doodle your ideas for furniture, room decorations, lighting setups, etc. The more you plan now, the easier it will be to bring your vision to completion. Setting up Blender. Begin by opening Blender and selecting General from the new File menu. From the File drop-down in the top left, select the Save or Save As option and choose a spot to save your work. Next, we are going to change how Blender displays objects in the viewport. In the top right side of the viewport are the display options. These are from left to right. X-ray mode, wireframe mode, solid mode, material preview mode, render preview mode. The down arrow to the right has different options depending on which mode you have selected. To set up your display so it matches mine, do the following. Choose Solid Mode. From the arrow drop down. Lighting, choose Matte Cap. Color, choose Random, this will assign a random color to each object you create. There are many options to explore, so take some time to get to know them. Now would be a good time to save your file. Blender offers different ways to save your file incrementally and otherwise to help you keep track of your progress. Save often and have many backups of your work. Accidents happen. Modeling in Blender is the process of creating 3D objects. Think of it like sculpting or building with digital clay or blocks to make shapes for your scene. Here's how it works in simple steps. Start with a basic shape. You usually start with something simple, like a cube, sphere, or cylinder. These are called primitives. Edit the shape. Switch to Edit mode, where you can tweak the shape by moving, scaling, or rotating parts of it. Work with vertices, edges, and faces. Add detail, use tools like extrude, bevel, or loop cuts to make the object more complex and detailed. Combine shapes, join multiple shapes together to make more complex objects, like building a car from cylinders and cubes. In simple terms, modeling in Blender is about shaping and combining 3D objects to create anything you imagine, from simple items like a mug to detailed characters or environments. We will begin modeling by blocking out the major models for the scene. In 3D terms, blocking out is the process of creating a rough draft of our scene using basic shapes to establish placement and proportions. Once everything is blocked out, we will begin adding details. To create our models, we will use a combination of destructive and non-destructive modeling techniques. In Blender, destructive modeling means directly manipulating the geometry of an object, permanently altering its shape and making it difficult to go back to previous versions. Non-destructive modeling uses techniques like modifiers and parametric controls to change the object's appearance without permanently altering the underlying geometry, allowing for easy adjustments and reversions later. Let's get started by deleting the default cube. Select the cube and press X or delete. Blocking out. To create the room, press Shift+A to open the Add menu, then navigate to Mesh Cube. This will add a cube primitive to the scene. Once the cube is created, press N to open the right side panel to view the cube's properties. Under the Item tab we see the cube's location, rotation, scale, and dimensions. The cube is 2 meters by 2 meters by 2 meters. With a scale of 1. To begin modeling the room, select the cube and press Tab to enter Edit mode. The changes we make while in Edit mode are considered destructive and not easily undone. Once in Edit mode, the Selection mode will be available in the top left of the viewport next to the words Edit mode. These are Vertex, Edge, and Face selection modes. The keyboard shortcuts for these are 1 for Vertex, 2 for Edge, 3 for Face selection. Choose Face selection mode, then select the top face, hold Shift, and select the 2 faces nearest the camera. Pressing X or Delete will bring up the Delete menu. Choose Faces from the options. This will delete the selected faces. Press Tab to exit Edit mode and return to Object mode. You can also click the Edit mode drop-down menu, then choose Object mode from the options. A face only has length and width, no depth. To add some depth to the walls and floor of our room, we will use a Solidify modifier. The Solidify modifier is an example of non-destructive modeling. With the cube selected in Object mode, select the wrench icon from the Properties editor. Click the Add Modifier button. Blender has many modifiers to help us model in a non-destructive way. They are grouped by what they do. The modifier we want is called the Solidify modifier and can be found under the Generate tab. Choosing it will add it to the cube. A model can have multiple modifiers applied to it. The order in which the modifiers are listed changes how they behave. You can rearrange them after they are added. Once added to the model, each modifier will have its own properties that we can adjust. The Blender manual describes each modifier and its properties in detail. For now, change the thickness to 0.1 and tick the even thickness option. This will be the basis for our room. If you wish to revert your model to the previous state, simply remove the modifier by clicking the X in the top right corner of the modifier window. To make the modifier permanent, click the arrow drop-down and choose Apply. This will make the modifier destructive and not easily undone. Now that we have established the dimensions of the room, let's start blocking out the furniture that will fill our room. Open the Add menu and add a cube. We will use the Scale tools in Object mode to shape the cube into a mattress-like shape. Remember, you can bring up the Transform gizmos by selecting the tool from the left-hand menu or in the Show Gizmos drop-down in the top right of the viewport. I will be using the shortcut keys we learned in an earlier video. G for Move. R for Rotate. S for Scale. Pressing G, R, or S followed by X, Y, or Z will constrain the transform to that axis. When using this method, be aware that your mouse position in relation to the object you are transforming will have an effect on how it transforms. It's a little difficult to explain, but test it for yourself by choosing S to scale with your mouse close to the object. Then far away from the object you are scaling. If there is sufficient room between your mouse and the object, the transform will be much easier. With the cube selected, press S then Z to scale the cube along the Z axis, left click to confirm the transform. Repeat the process on the X and Y axis until you are satisfied with the mattress shape. If we look at the object properties now, we will see that our scale is no longer 1. It is important that the scale be 1, as it will affect the behavior of our modifiers. We will fix this later in this tutorial. Use the shortcut key Shift+D to create a copy of the cube. The copy will automatically be attached to your mouse. Press Z to move the cube up on the Z axis. Left click to confirm. Using the Scale tool, reshape the new cube to be the headboard of the bed. Use the Move tool to position the headboard at the top of the bed. G to move then the axis you want to move on X, Y, or Z. Press Shift plus D to create a copy of the headboard, then position it near the foot of the mattress. Select all three objects that make up the bed and position them where you want them in the room. If needed, refine the scale to better fit the room. Add another cube, this will be the bookshelf. Use the scale tools to reshape the cube into a rough bookshelf shape. Remember, we are in the blocking out stage, we will add details, such as shelves, once the blockout is complete. Use the Move tool to position the bookshelf where you want it. Using the shortcuts for transforming G, R, or S, along with the shortcut to constrain the axis of transformation X, Y, or Z lets you move only on that axis. If we instead press Shift plus X, Y, or Z, it will exclude the selected axis and allow movement on the remaining axis. For example, if you press G then Shift plus Z, you can move the object on the X and Y axis. Position the bookshelf where you want it in the room. The desk will be made from two separate objects, one to be the top and one to be the legs. Let's begin with the top. Add a cube, then use the scale tool to reshape it into the top of the desk, then using the Move tool reposition the desk where you want it to be. Up to this point we have left the 3D cursor at the origin. We can move the 3D cursor to make placement of the models easier. For instance, we can place the cursor at the pivot point of the tabletop we just created before we add the leg. To do so, do the following. Select the table. Press Shift plus S. Then choose Cursor to Selected. The cursor is now positioned at the center of the tabletop. Now add a cylinder to the scene. Take note of the last action panel that appears in the lower left corner of the viewport. This panel will allow us to modify certain settings of the last action taken. In this case, we can modify the number of vertices the cylinder will have. Since we are working in a low poly style, change the number of vertices to 8. Use the scale and move tools to resize the cylinder into a leg, then position the leg near the corner of the tabletop. Instead of making 3 copies of the leg, we will instead use a mirror modifier to create the other 3 legs. Do the following. With the leg selected, choose the wrench icon in the Properties editor. Click the Add Modifier button. If you know the name of the modifier you want to add, you can simply type the name to bring it up. Type mirror and the mirror modifier will come to the top of the list. In the mirror properties, we can choose which axis to mirror. Take X and Y. Next, we choose which object to use as the mirror object. Click the eyedropper and select the tabletop. If executed properly, you should see 4 legs positioned in each corner of the table. Doing this will allow us to modify one leg and have it take effect on all 4. Note, you cannot modify the copies individually unless you apply the mirror modifier, thus making the copies actual geometry. The creation of the chair is similar to the creation of the table. Add a cube to be the seat of the chair, then modify its scale and position. Create a cylinder for the legs, resize and position it, add a mirror modifier to the leg, tick both X and Y axis and assign the seat of the chair to be the mirror object. To make the back of the chair, press Shift plus D to duplicate the leg, move up into position, then untick the Y axis on the mirror modifier. Either add a new cube or duplicate the seat to complete the back of the chair. Adding detail. Now that the blockout is complete, let's begin adding details to the models. Most objects have rounded edges on them. One way to accomplish this in Blender is to use a bevel modifier. Select the mattress model and add a bevel modifier to it in the Modifier Properties panel. The bevel is not applied evenly onto the model due to it not having a scale of 1. To correct this, we need to apply the scale from earlier. Open the End panel in the 3D viewport and find the scale property of the cube. Press Ctrl plus A to open the Apply pop-up window and select Scale. This will reset the scale to 1 and fix the issue with the bevel modifier. You always want your objects to have a scale of 1. By changing the properties of the bevel modifier, we can adjust how the bevel looks on the model. Giving it the beveled edge makes it look more like a mattress, rather than just a rectangular box. Press Tab to enter edit mode. We will use the Loop Cut tool to add a set of edges to the model. Select the Loop Cut tool from the toolbar on the left. Add a loop cut by hovering over the long edge of the model. A yellow edge will appear running perpendicular to the edge closest to the mouse. Clicking and holding will allow you to slide the new edge with the mouse, release to confirm. This action has added a new set of edges to the model. The shortcut for the Loop Cut tool is Ctrl+R. We will duplicate and separate these new faces to be the blanket on the bed. Return to the Select Box tool, then activate Face Select mode. Select the faces as shown. Press Shift+D to duplicate the faces. Right-click to return them to their original positions. The duplicated faces are still selected. Press P to open the separate window. Choose Separate by selection. By loose parts would have also worked here. Press Tab to exit edit mode. Select the newly created model and add a Solidify modifier to it. Adjust the settings of the Solidify to add thickness to the blanket. Now select the headboard model and press Shift+A to apply the scale. Press Tab to enter edit mode. We are going to add a series of loop cuts. Press Ctrl+R to activate the Loop Cut tool. Hover over the horizontal edge of the headboard. Instead of clicking, roll the mouse wheel up. This will increase the number of loop cuts that will be created upon confirmation. Add 6 loop cuts by rolling the mouse wheel, then left-clicking to confirm the number of cuts. At this point you can slide the cuts and left-click again to place them, or right-click to place the new cuts at the default even spacing. Note, this behavior, rolling the mouse wheel to add or remove loop cuts and sliding, is only available when using the shortcut key to activate it. Clicking the button to the left behaves differently. Select the 2 top end faces and choose the Extrude button on the left. Extruding moves the selected faces and creates new geometry to keep it connected to the existing geometry. Click and drag the yellow plus sign to extrude up the corner posts for the headboard. The Extrude tool has a little arrow in the bottom corner. Remember that means there are tool options under there. Click and hold to access them. 2 additional ways to access the Extrude tool are E and Alt+E. Next, we will use proportional editing to create the arch in the middle. Proportional editing allows us to select a single face and exert a variable amount of influence on the faces surrounding it. To activate it, click the Proportional Editing button in the top middle of the 3D viewport. The default options will do for this instance, but be sure to explore the options. Select the middle face and press G then Z to move the face up. A circle should appear around your mouse. This is the area of influence for the editing. Scrolling the mouse wheel will grow and shrink the circle. Experiment till you get a shape you like. Note, if your entire object moves, then your area of influence is likely too large. Once you are satisfied with the shape, left-click to confirm. Don't forget to disable proportional editing, then press Tab to exit edit mode. Use Shift+D to duplicate the headboard, then position and scale to fit as the footboard. Don't forget to apply the new scale before moving on to the next step. The bookshelf. Select the bookshelf, apply the scale, then tab into edit mode. Add 3 loop cuts with the Loop Cut tool. Select the 4 faces on the front of the bookshelf. We will be using the Inset tool. This time we are skipping the button and going straight to the shortcut key. Press I on your keyboard, then move the mouse slightly towards the model. Think of this as adding a frame of polygons to the selected polygons. Similar to extruding. Pressing I again will change how the inset appears. Either as one big inset across all selected polygons or as individual insets on each polygon. We want individual insets on each polygon. Inset just a little, then left-click to confirm. Press E to activate Extrude, Then move your mouse so the faces move into the model, thus creating the shelf cavity. Simple yet effective. Select the desktop model and apply the scale. Adding a bevel modifier and adjusting the properties gives it a nice, rounded edge. For the legs, select the Leg Model tab into Edit mode. Select the bottom face, press S to scale the face down, creating a tapered leg. The chair will be detailed using the same techniques. Parenting objects. Several of our models consist of multiple parts, necessitating the need to select all the objects to reposition them. We can create a parent-child relationship between them, so we only need to grab the parent and the children will follow. We do this by selecting the children objects first and the parent object last by holding Shift. Press Ctrl+P, then choose Parent. After doing this, we need only select the parent object to move, scale or rotate the entire object. When selecting multiple objects, the last object selected is referred to as the active object. We will learn more about the active object as we explore Blender. Texturing in Blender is the process of adding colors, patterns, or images to the surface of a 3D object to make it look more realistic or artistic. Think of it like wrapping a gift. The wrapping paper is your texture, and the gift is your 3D model. Here's how it works in simple steps. Create or find a texture. You can paint your own textures in Blender, use images you find, or create patterns with Blender's built-in tools. Apply the texture to the model. Blender uses a system called UV mapping, which tells the texture how to wrap around your 3D model. Imagine unwrapping a box into a flat shape and then drawing on it. That's UV mapping in action. Fine-tune the material. The texture is part of a material. A material controls not just the color, but also how shiny, rough, or transparent the surface appears. Preview and adjust. Use Blender's 3D viewport or rendered views to see how the texture looks on the model. You can adjust settings to make it just right. Texturing can be a complex topic, so we are going to start slow and build over time. To begin, select the model you want to add a material to, then choose the material editor from the Properties editor. Click the New Material button to create a principled BSDF material and add it to the selected object. The principled BSDF is a versatile base material with many options and parameters that is suitable for a variety of materials. For now, we are going to look at some basic options. The material can be renamed by clicking on the material .00 and entering the new name. In the surface rollout, there are options to change the type of BSDF material it is, the color of the material, the metallic and roughness properties, and more. Hovering over these will give you a description of what it does. We will explore more of these parameters in time. For now, focus on changing the color, metallic, and roughness properties. Some materials will be glossy and others matte. This is controlled with roughness. A value of 0 gives a material a mirror-like surface. Some will be metal, some will be plastic. Experiment and create a palette of 5 materials with different parameters and apply them to your models. In essence, texturing gives your model its personality, turning a plain object into something that feels real or fantastical. Lighting in Blender is about placing lights in your scene to make it look realistic, dramatic, or artistic. It works just like in real life. You need light to see things, and the way you place lights affects how your scene looks. Here are the basics. Types of lights. Point light, like a light bulb, it shines in all directions from one spot. Sunlight, mimics sunlight, casting parallel rays across the scene. Spotlight, like a flashlight, it shines in a cone shape. Area light creates soft, even lighting from a flat surface. Environment light adds light to the whole scene, often using an image to create a realistic outdoor or indoor effect. You add lights just like objects, and you can move, rotate, and scale them to get the right effect. Adjusting brightness and color, lights have settings like brightness, called power, and color to control how intense or warm/cool they look. Shadows, lights can cast shadows, which add depth and realism to your scene. You can adjust shadow settings to make them sharp or soft. Experiment and preview, use Blender's rendered view to see how your lights affect the scene and adjust them until it looks just right. In simple terms, lighting sets the mood and brings life to your 3D scene. By default, Blender provides a single 1000-watt point light to illuminate the scene. This is rarely sufficient. There are many ways to light your scene. A 3-point light setup with a key light, a fill light, and a back or rim light is a good place to start. But lighting setups are a discussion for another video. I will say this: when creating lighting for your scene, look to the real world for placement, power, and coloring inspiration. An alternative way to light the scene is to use an environment texture. This is a special type of image called an HDRI or high dynamic range image. These images can be found online by searching HDRI lighting. They consist of 360-degree images of different environments that can be used to generate the lighting for the scene. Download the HDRI from polyhaven.com or another site and save it in a project folder of your choosing. In Blender, select the Shading tab from the workspaces across the top of the screen. Here we will create a simple node tree to use the HDRI as the lighting source in our scene. A node tree is a set of instructions for whatever we are creating. Blender uses nodes in many different places. Understanding them is foundational to learning Blender. We will be talking about them quite a lot as we explore Blender. As I said earlier, start slow and build. In the shader editor at the bottom of the screen, click the Object button and choose World. To focus the view on the world node tree, do the following. Press A on your keyboard to select all, then press period on your numpad to zoom to selected. If you do not have a numpad, click the View dropdown, then Frame Selected. This shortcut combo works in most editors. Press Shift plus A to add a new node. This will be an environment texture node. Type environment, then select the environment texture from the list. Left-click to place the node in the work area. Click the Open button, then navigate to where the HDRI is saved. Connect the environment node color output to the background node color input, which then outputs to the world output input. Congratulations, you have created your first node tree and thus learned your first lesson in nodes. Outputs are on the right side of the node, and inputs are on the left side of the node. So, a node tree is read left to right. Change your 3D viewport to the rendered option to preview your new lighting. Rendering in Blender is like taking a photo of your 3D scene. It turns the 3D models, textures, lights, and effects into a final, realistic image or animation you can share. Here's how it works in simple terms. Set up your scene, make sure your models, textures, and lights are ready and look good from the camera's point of view. Position the camera is your viewpoint in the scene. You can move and angle it to frame your shot, just like taking a picture. Choose a render engine. Blender has two main engines for rendering. Cycles creates highly realistic images but can take longer. Eevee, faster and good for less detailed or stylized results. Click Render. When everything is ready, you hit the Render button. Blender processes all the details, lighting, shadows, reflections, textures, to create the final image or video. Save your work. Once the render is done, you can save the image or animation file to share or use in a project. In short, rendering is the last step where Blender turns your 3D work into a polished, shareable masterpiece. Setting up render save options. Throughout this semester we will use both Eevee and Cycles render engines. Beginning with the Eevee engine. From the Render Properties tab, choose the EV Render Engine. Tick the box next to Ray Tracing to enable ray tracing for EV. Select the Output Properties. Here we can set the resolution and type of file we are saving as well as where to save the file. The default is your /tmp folder. Not a great place to save your renders. When you are ready to render your image, click the Render dropdown, then Render Image or press F12. This will open the Render Image window. Once the image has completed rendering, choose the Image drop-down menu, then choose Save or Save As and save in an appropriate folder. Next steps. Now is the time to put what you have learned to use. The room we created has the basics needed but is still lacking in character. Think of all the objects in your room. What do they say about you? Plan and create between 5 and 10 models to fill out the scene. Place them around the room, on the desk, bookshelf, or the floor. Wherever you want them to go. Use these items to tell us about the person who lives in the room. In 3D terminology, these items are called entourage and are an important element in any scene we create. Render your scene from 3 or more angles. Write a one-page reflection discussing what you created. Submit both your renders and reflection before the due date. See assignment for full instructions. Thank you for watching. I look forward to seeing what you create. See you in the next one.